Okay, we're going to do the first two in chapter 3 today. We'll take a break from it tomorrow, and then we'll resume later in the week. Okay, how you do today will affect how the rest of the week goes. I think you can handle it, but you want to pay careful attention. Okay, quick reminders. I was doing this thing again, really. Quick reminders about notation. Okay, so a little reminder. You had a slight break from having to always indicate, is it a line, is it a segment in the last chapter, only a little bit, it is back. Okay, so if they tell you lines, I know it's a little misleading when they draw this like a segment, but when they tell you all lines parallel to RV, they're indicating RV is a line, that means all of them are a line. I wish it was a little bit more clear, but you can't just write TXQU, that will never actually work right there. Okay, hopefully the first couple were okay. Little reminder, these are all coming back. Alternate exterior, alternate interior. You did learn those briefly yesterday. We'll spend more time. Vertical didn't go away. Okay, corresponding, we talked about yesterday. Supplementary doesn't go away. They call this consecutive interior. What did we call it yesterday? Not consecutive. Same side. You're going to see that more often than not. Okay? Yes, well there it is right there. I just pulled it up very quickly. I wish I could tell you, well, what is it? Just
it's the 6-7
the 6-7 monster?
6-7 monster.
The 6-7 monster. Yes.
Who drew that?
Yeah. Okay.
6-7 monster.
I actually thought you did pretty well with this yesterday. Okay. In terms of identifying, the one thing that you do have to do if you're going to work with problems like this, you have to kind of reset the diagram. Okay, what I mean is, the first one, corresponding angles can be created with A, B, transversal D, and that gives you, yes, angle 7 and angle 6. And then when it's time to do this one, you kind of need to reset the diagram, at least in your mind, okay, or you could just be crafty and try to slide this transversal down. Okay, but you have to kind of reset every single time. Okay? Yes.
For 4 and 5, I was confused because it says C and B are the
4 and 5.
like the on 16 for like the angles 4 and 5.
Oh, not questions 4 and 5, angle 4 and 5. Okay, so you want to talk about this one?
Yeah, but like the angle 4 and 5, it says like it says C and B and then E. But
So C, so B, C and E.
and then I thought like
What is all this? You got strangers walking in. I'll check with you later. I got my strangers walking in here. Okay. How do always, sometimes, and nevers go? What was that?
It's like a permission.
Oh, you got swifted. Oh no, you're not swifted. You're no. Okay. What is it? I'm just used to saying swifted because usually you get swifted. You know what I'm talking about. Okay. I gotta check on that one a little bit. How do always, sometimes, never go? Better? I feel like you've come a long way with these questions. I feel like you have to really think it through. Remember, if you can find at least one counterexample, then it can't be always. Usually it becomes a sometimes. Okay? And then same kind of thing for this guy. They gave you 4 blanks. There should actually only be 3 of them. Okay? I think the first 2 should have been good. Let's talk angle 20. So this time, it's the same diagram from class. We want corresponds with 4. So the last one's probably usually the goofiest. D and C are your lines. Remember we talked about this yesterday? You have to make sure the angle is created. So if I just do transversal B, it doesn't actually create angle 4. I have to create transversal A, 4 and 20, of course. Okay, good times. Okay, it's going to be a fairly heavy class, so I kind of want to see how you do this stuff. So we're going to roll through the warm-ups kind of together. All right. Okay. Proofs are back. They never really went away, but they're here. I'm just going to pick people because we should be able to do this one even just on the fly right here. Okay, so the first step is given. 3 times x plus 2 equals 5x. Let's go, Kennedy. Reason for the next step? Distributed. Remember what I told you last time when I went over the test? Just call it the distributed property. Don't worry about of equality or anything. Don't even bother. Just call it the distributed property. Okay. Let's see. How about Sawyer? Next step.
Subtraction property of equality.
Looks like they subtracted 3x from each side. Catherine, how about the next one?
The division property
Of equality. Yes. Anybody know the last one? We haven't seen that one in a while. Okay, Marissa. It's not transitive. Not transitive. Ronan.
Symmetric.
You haven't seen that one in a while. Symmetric property of equality. If A equals B, B equals A. Okay. Good times, good times, good times. Not good times, I don't know. Awake? Awake times. Okay, good, we keep going. Ooh, which is the proper symbol for congruent? Yay, good job. Equals, what's that? Parallel, good times. Okay, acute, obtuse, or right. This first guy clearly obtuse, right? It's nice when it's labeled. This is right. This is acute. Acute little angle. Okay. So a little reminder yesterday, when we did alternate interior angles, a couple of you weren't getting the interior part. So just remember, interior is inside. That means you're inside your lines. Then the transversal was kind of cutting through. So anything in between is interior, anything outside is exterior. Okay, but we're going to really go back to some familiar stuff with those things. So the interior, if they gave you this circle, the interior of the circle corresponds to point, which part here, A? And the interior of the angle, yeah, it's B. You see this stuff later in the course. I love these questions, but I don't think we get to them for a long time. Where you have a circle, you have this angle, and we're going to be talking about like this arc, okay? But this is the angle right here. C is on one of the rays, A is the vertex, B is inside the actual interior of the angle. Okay? The end point of an angle is the vertex. Very good. Okay, and we know how to name the angle, so I'm not going to have you bother with that. So, okay, cool. So yesterday we started talking about this stuff, and one of the things I told you was when we showed it to you in 7th grade, the lines were always parallel. Yesterday they weren't. Today they're going to be, and then we're going to talk about proofs that kind of go along the way. So quick conversation with anybody around you. See if you can name all of the angles that fall in each category. You don't need to write them down, but just see if you can name all of those based on this diagram. All right, here it is. Jack, same side interiors. Hit me.
3 and 5.
4 and 6. Good. Okay, cool. Let's see, Isaac, alternate interiors.
4 and 5 and 6.
Okay. Sari, corresponding.
2 and 6 and 1 and 5.
And 3 and 7. 4 and 8. There's a lot of them. Okay, and then let's go with Cam, alternate exterior angles. Beautiful. Okay. So when we gave you a diagram like this last year, you all crushed it. I know you did. I have the proof. The reason is because when the lines are parallel, the relationships are fairly obvious. Okay. In fact, you can see a bunch of angles on there that you know are congruent and some that are not. The issue with the rest of the week is we're going to have to prove everything. That's something you didn't have to do last year, okay? So lots of postulates and theorems today. Now remember, you got to pay very careful attention to when something is a postulate. If it's a postulate, it's given as a reason, it would never be proven. It's accepted as truth. So call it a postulate. What's the other word you could use for it? Axiom. You can use either one, okay? But sometimes they're theorems, you have to quote them properly. Okay, postulate 3.1. If a transversal intersects 2 parallel lines, then corresponding angles are congruent. Good job. Okay, that is the corresponding angles postulate. Yes, you would definitely have to quote that in a proof. If you were to quote that in a proof, you could abbreviate it like this. That would be allowed. Corresponding angles postulate, or you can write the entire word out. But I would accept corresponding angles postulate like that, or axiom. I would not accept theorem. Remember, a theorem can be proven. This cannot, but it is accepted. 1 is congruent to 2. So going back to this diagram right here, 1 is congruent to 5. Okay, what else is true here? 4 is congruent to 8. What else? 2 to 6, but notice I'm marking it this way because they're not necessarily all congruent to each other, and 3 matches 7. You kind of knew that last year, but the lines were always given as parallel. Okay, what about same side interior angles? This is your next postulate. If a transversal intersects 2 parallel lines, same side interior angles, are those congruent? There's no way they're congruent, but guess what they are? Supplementary. I told you it wasn't going away. How could you abbreviate this one if I was giving reasons? And if I show you it's allowed for an abbreviation, it's allowed. Okay? Or you can write out the whole thing, but you can do SSI. I'll know that means same side interior angles, postulate. Okay? Cool. So if we were identifying supplementary angles, the measure of angle 3 is 55. So if the measure of angle 3 is 55, what a lot of you probably did last year, you probably just filled in all the 55s, right? Like that's 55, that's 55, and that's 55. And then what do the rest of them have to be? Not 55 is not a good enough answer. Huh? 125. How'd you get it? This work and this logic and this like quick, efficient way is super great if the lines are parallel. Remember, they don't have to be. They did last year, they don't have to be. All these postulates we just had, the 2 of them, if a transversal to intersecting 2 parallel lines, it's given. If a transversal is intersecting 2 parallel lines, it's given. If they're not given, you can't kind of fly through this a little bit. Okay? Now we're into theorems, which means we're about to prove them. The alternate interior angles theorem. This is not a postulate. This has to be proven. If a transversal intersects 2 parallel lines, then alternate interior angles, guess what? They are congruent. So this can be quoted, but it can be proven, which we're going to do now. How could you abbreviate this? Because I know you're interested in the abbreviations. I would think about this. Alternate interior angles. You can abbreviate theorem with THM if you want. It's pretty universal. Okay. There's a small proof of it right there. I want you to see if as a group you can come up with the reasons for it. Read each statement very carefully. This is the alternate interior angle theorem. Look at what you're given. Look what you're trying to prove. Here are the statements. See if you can come up with the reasons together. It's 4 of them. Helpful. That's a good way to do them when you start doing them from scratch. That'll help because if you look at the bottom, that one's starting from scratch. Shouldn't take you too much longer. It's nice when it's laid out for you. Then we'll get to the fun times. Just this proof. Then we'll talk about how to get yourself ready for the next one. Yo, go pencil down when you got that one filled in, just so I know. Pencil down when you got that one filled in. It's a little flip action. How long did it take you to draw that?
He just drew it out.
Come a long way from your compass muscle dudes. Okay, so anybody that's looked ahead, I know a bunch of you probably have because that's what you do. You will notice the next one is a start from scratch proof. Did you see that underneath it? So here's the question, okay? And Cam just kind of said it to me, which I'm glad because this is what I would do too. Once you know something is a theorem, rather than look at what could be given for you in statements, you should kind of think to yourself, okay, how would I walk through this proof if I had to on my own? The more you start to do that stuff, the better you'll get because, yeah, the next one, it's a start from scratch. And I won't even tell you there's 4 statements next time. Okay, so you gotta get a little bit better at this stuff in chapter 3. The question is, how on earth do you create a proof from scratch? I typically start with the diagram. I look at the diagram, I look at what's labeled, and then I just start with the given. And what is the given, everybody? A is parallel to B. That's it, right? Yeah? Okay. So then I'd say to myself, okay, I know a lot of things about parallel lines. I know things that could be congruent, but I still need to walk through what a proof might look like. What is our ultimate goal? Our ultimate goal is to get 1 congruent to 3. So if I was in here, I would say, okay, there's no way I can go right from 1 to 3, but can I relate anything else to 3? 25.
No, I said 1 and 5. I was looking at the other
There is no
side.
5. Can I relate anything else to 3? I can relate 2 to 3, and then I would say, okay, can I relate 2 and 1 at all? Yeah, then I can start to see how this thing connects. So I know some of you haven't hit the frustrating part of proofs yet, because I haven't given you blank ones yet. It's coming. So you have to realize if I give you nothing at all, I say just prove it. The first step is probably just walking through in your mind, what do I know and how can I connect it? Eventually you get a little bit better at it, okay? So this one shouldn't have been too bad because I gave you all the statements, okay? First reason, last view, pretty much always given, okay? Angle 1 is congruent to angle 2. Anybody got that for me? What do you have for a reason for this one? Should be plenty. Conlon. Corresponding angles postulate, or axiom. You cannot say theorem. Now that's nitpicky, but sometimes math is nitpicky. Okay, the corresponding angles postulate says 2 is congruent to 1. Then they said, oh, I can relate 2 and 3. Vertical angles theorem. Now, question before we go on. If I was constructing this proof from scratch, could I have flipped steps 2 and 3? Yes, it would not have mattered, okay? It would not have mattered. I could have done the vertical angle theorem right out of the gate, then I could have done corresponding angles. So there's a little bit of wiggle room, okay? Last step, angle 1 to angle 3. Transitive property of? We can't say equality, congruence. Congruence, okay? Last step, QED. There it is. Somebody in period 5 said it's kind of like you say like amen at the end of a prayer. I like that. Closes it out. And as I'm done, finished, ready to move on to the next thing. Okay? So I like what Cam said though, because this is what I need to instill in you. Even though you had the idea of it laid out for you, when you see the word theorem, you should be thinking of a plan of attack on your own. That being said, I want you to see if you can prove this on your own. No friends, no enemies. Just you. Hello. Time. Yeah. Yep. Just you. Little hint from me, you can do it in 4 steps. Look at what you're trying to prove. what you'll see more of in chapter 3, kind of thrown in the deep end of proofs. You do start to see patterns. Okay, and at this point, check in with somebody. Either here's what I got so far, here's what I finished with, or I don't know where to go from here. Check in, see where you're at. I'll give you your first reason, because a lot of you seem lost.
That's you have to prove. You have to prove that one and eight is
Notice at no point does it say that the measure Yes. Why? And you had his hand delivered here. Your first step. All right, so let's take a look. Now, the other thing you have to keep in mind, sometimes less is more. So you have to really think to yourself, okay, what do I need to prove, and am I bringing in unnecessary things? Little fun fact, if you don't have a definition in there, this one's not going to go anywhere. Think about this. I look at this diagram. A is parallel to B. So I'm starting to run through all the stuff in my mind that I know. I need to prove angle 1 and angle 8 are supplementary. At some point, I need some definition in there that allows me to bring supplementary into the mix. Okay, so just kind of keep that through. I also can't use the same side interior, the one that we wrote down earlier. Why can't I use it? I don't have any. There are no same side interiors. You can't create your own angles on the diagram. So if you try to do stuff like that, that's not going to work. It's created, okay? Everybody should have the first one. Copy the statement. A is parallel to B. Given. Take the free point. Take it, okay? Because it's better than nothing at all, okay? Now we need to start figuring out kind of what's going on. So I'm looking at the diagram based on everything we've done in class. I know I could get these guys congruent if that would help me. I should know what's going on here based on previous work, okay? So does anybody want to try to kick us off with a second statement? Now we might not go in the same order, okay, but that's okay. Elena.
Angle 1 is congruent to angle 5.
I kind of did that too because that's what we did earlier in class. Did anybody else go angle 1 is congruent to angle 5? Do I need to bring in measures? No. You'll see why in a little bit. Reason?
Corresponding angles postulate.
Corresponding angle postulate. Okay? So right now, I've used 1 and 5. I've got to figure out a way to involve 8. Anybody think they have a third step for me? Third step. Okay, it's like second step, but one more. Grace?
I said
Angle 5 and angle 8 are supplementary, or angle 5 is a supplement to angle 8. You can word that however you want. Grace, what is the reason for that? Ooh, close though. I can't say they're supplementary and say the reason is because I know what supplementary angles are. This was something that some of you never quite latched onto. No, it's not the angle. The angle addition postulate is angle 8 plus angle 5 is the angle of 8 plus 5. Not quite. Definition of a linear pair. I can't say they're supplementary because I know what supplementary is. Why do you know they're supplementary? Because they're next to each other, and what do they make? A line. Oh, guess what definition that fits? Linear pair. Some of you just never latched on to linear pair. Some of you do and you forgot. Some of you act like it's never going to come up. Okay, so Grace's statement is perfect. But if the reason is definition of supplementary angles, what's its definition? Angles that add up to 180? I don't have any angle measures. There's no numbers on the diagram. But I do know that they make a line, and I do know that adjacent angles next to each other that make a line are supplementary. It's nitpicky, but guess what? You'll get better at it. Did anybody actually write down definition of linear pair? Guess how many people I figured would. But anybody come up with what Grace wrote? Anybody write angle 5 and angle 8 are supplementary? You're on the right track. You are 100% on the right track. Do we have questions about why that's the reason? You can try to argue it, but you probably won't win. Yes? No, that's the only thing you could write. Definition of linear pair, angle 5 and angle 8 are supplementary. You can't say they equal 180. We have no angle measures on the diagram at all. This is the only step we could have. I anticipated people would write this. I didn't anticipate a lot of people would write this, but I need you to see it now. If you don't believe me, look up the definition of linear pair. Okay? Now we're close. Maybe they can finish it off. We're close. Okay, Sawyer.
Angle 1 and angle 8 are something.
Reason?
Transitive property.
No.
Substitution.
Substitution. Which I believe I told you could just write substitution. Actually, we're not done. We missed something. Yeah, QED. Good job. Okay. Now, I know what you're thinking. A lot of you probably think, geez, I didn't get it. I can almost guarantee for most of you, it was just this step. You'll figure it out. You have to know why that's the only reason you can give, though. 5 and 8 are supplementary. Yikes. The only reason I know they're supplementary is because I know what a linear pair is. I don't know it for any other reason. And here's why a lot of you will hate the class. Because it's obvious. Look at the diagram. They're clearly supplementary. But you have to give the correct reason. You will get better at it. You see why I didn't throw you in the deep end with proofs on chapter 2, yes? Yes, okay? And I'm not even throwing you in yet. I'm telling you to put your feet in the deep end a little bit. You'll get there eventually. Questions about that? Okay, cool. Couple more theorems and then good news. We don't have any more proofs today. Yeah, they're coming back, don't worry. Alternate exterior angles theorem. If a transversal intersects two parallel lines, alternate exterior angles. Say it with some conviction. Are congruent. Good job. Alternate exterior angles are congruent. I know you're going to be fine with the rest of the stuff from class based on what I've seen that before. Question?
Why do we have to prove some of them and then not?
Oh, good question. Really good question. She just asked, why are we proving some and not others? Because the proofs are redundant, so they're very similar. So I could make you prove all of them, I suppose. But the proof for this is remarkably similar to the proof for the alternate interior angle.
Why are some postulates and why are some theorems?
Because the postulates can't be proven. So your question.
What's the abbreviation for this?
Abbreviation for alternate exterior angle theorem that I would take. And it's up to you. Most of you don't like putting this whole thing in, but you can just do angles the way you get that as well. Okay. Lane asked a good question. Why aren't we proving all the theorems? They're redundant. I already showed you the alternate interior one, so I could show you this one, but it's exactly the same. They come up a lot in the homework and other spots, so we don't have to prove every single one. Okay, it's kind of the idea. So how could I, again, use diagrams to prove all of these things? Measures of angles 3 and 4. If I was going 105, I don't know, there's a lot of ways you could prove it. What a lot of kids like to do is to just fill in all the 105s. Anybody see another 105? Angle 5, because they're corresponding. Who else? 7, because they're vertical, which then means what? 3, which then means, and then all the rest are 75. I'm not worried about these questions. There's a reason I gave them to you last year, because you have to see them as 7th graders. It's the names and all the definitions and the proving that is a little bit more annoying, but these questions shouldn't be too bad, okay? So the actual finding of angles inside of diagrams, okay, there's a whole bunch of them. The only thing I'm going to tell you is, even though you don't have to write reasons for them, you should be ready to tell me any of the theorems you use. So if all it says is find the measure of angles, no proof is required. Yay. But I would be ready, because if your answer's wrong and I say, how did you get it, you should be able to give me a little bit of something, okay? So there's a bunch of them to do. Some of them are straightforward and some are tricky. There's this one, and then there's the trapezoid, okay, and then a couple other questions down there. I'm gonna turn you loose on all of them as a group. Find all of the angle measures, okay? Each of them have like 2 or 3 different angles. Be ready to prove to me how you got it, even though it doesn't ask for proof.
Wait, isn't there,
There's A, B, and C. How do we feel about A being 65, B and B and 75, and C being 40? Let's see, thumbs up for that. Yeah? Did anybody use the alternate interiors like I did? You didn't have to. These are 65, these are 40. You can get this from any which way, the triangle, the line. There's like no, there's not just one way to get it. You gotta use the parallel lines though. Track is always, let's throw back. It's not that negative. It's gonna have to be like that. Could it be equal? 2x equals x minus 12. See some of that.
Figured it out.
We are right back there. We need to be broken up.
We just saw that like remember the thing we learned that's like No, I don't. If you extend that line, then those okay, so these are parallels, you extend them to extend your lines.
We all done with the trapezoid one? No?
So then it's just 70. I said it first. Because 180.
First trapezoid one, x is 64.
Oh, and then y plus
Y is 40. We'll talk about that one a little bit more afterwards. Okay, man, finish up. Just a couple more comments on it.
I'm being a lawyer.
Last minute. Some of you are done and you're waiting to check. Some of you are finishing up. Okay, here we go. So, a couple things. Whoop. I do have things I want to talk about on each of them. Pay careful attention. Okay, this one sounded like it went okay. Again, you can do questions like this because you're using your theorems. You don't have to necessarily quote them. But for your own practice, the better justification you can give, the better off you'll be at the proofs. And I know the proofs are what have a lot of you nervous. Well, even though they didn't ask you to, I should be able to ask you, how do you know that? You should be able to give me an answer. Okay, that one should have been fine. Okay, how did the trapezoid one go, the first one? Okay, they told you right here, because the bases are parallel, same side interior angles are supplementary. Do not set these equal to each other. Did anybody set them equal to each other and get a negative answer? Okay, good. I mean, you should know it's wrong. But look at the diagram. If I extend these lines, if I cut a transversal, no way are they congruent, but they're same side interior, supplementary, same side interior, supplementary. Okay? Now I want to talk about this because this is going to help you down the line. It's coming. Okay? I didn't ask you to fill in the angle measures. We're going to do it now. So if I plug in 64, what's this guy? 52? What's this guy? Okay? And if y is 40, this is 120, and this should be 60. Okay? Same sides add up to 180. This is going to come up. What's the interior sum of the whole thing? 360. That's going to come back. So triangle is 180. Four-sided figure, quadrilateral is 360. I need you to keep that in the back of your mind when it comes up. Okay? I like these questions. You can only do this question realistically if they give you this. What does this mean? They're parallel. Otherwise, you can't. Somebody want to tell me, how do you do this question? Okay, Layla. So if you kind of extend this so it's more like what we're used to, these are parallel lines cut by a transversal. So if this is 50, she's claiming that is 50. And they didn't ask you for a reason, but if you had to in a proof, you'd say, oh, they're alternate interior angles, okay? Now, fun fact, I actually taught you this last year. Miss Galbraith taught you that, but most of you probably don't remember. There was a little exterior angle theorem. 50 plus 70 is 120. That actually is x, isn't that the answer? Yeah. Now, if you don't remember that, okay, then the other way to go about it is 50, or the whole thing I should say, is 120. Okay, but 50 plus 70 is what, 120? So this is 60, so this whole thing is 120, meaning if this is 50, guess what this guy ends up being? 70. Okay? Even if you didn't remember the exterior angle theorem, you can still get there. Okay, but you do need what Layla said as justification to provide that inside angle. Question? Yeah, but you still need to use the parallel line lines, the bottom line. You can use that as corresponding as well. Same kind of thing. Okay, and then the last one, knowing that they're parallel, you could write easy equations for this. Okay, what does 2x plus 90 give you? It's gone. Oh, it vanished. There it is. It did disappear on me. Okay, where'd the x go? Ah, there it is. You could write two equations. You could write 2x plus 90 equals 180, or some of you maybe went right to 2x equals 90, but x is 45. And then same side interiors, y plus y minus 50 equals 180. Okay, y should be 115. Last comment on these. Never be afraid to extend the lines if you need to in order to see all of the relationships that you need. It's okay. Okay, it's better than getting them wrong, just so you can see where everybody lies. Okay? One of the big things today, because the algebra stuff I'm not that worried about. Most of you are going to be fine with that stuff. You have to know these theorems and postulates. You can't survive the rest of the chapter without knowing them. So as you're working on your homework later and it has a proof, try to construct the proof on your own first. Think about, can I quote it without looking? At the end of the day, if you have to look at the postulates or the theorems, that's fine, but no, you won't be able to do that throughout the chapter. You will just need to know them. You don't need to know the numbers, like 3.1, 3.2. That's not necessary, but you do need to know all of them. Okay, any questions? Okay, so you can start looking at this. If you're nervous about the proof, there is one blank proof. So you can look at that first if you want, kind of up to you. Or you can just do it in order.
Mr. Patel, have you seen questions go on the homework?
I have. I'm not eliminating all the 67 degrees because people can't get over it. They're staying. For some reason, it's actually very common in a lot of geometry answers.